presentation last year before a live group, none of the wildlife biologists were available, so I got elected to do it. And because, as most of you know, I'm a fire guy and a plant guy and not so much wildlife. So I'm going to do the best I can. And the one thing I would like to do, though, is acknowledge those people that I've worked a lot with that are the wildlife biologists. Carrie Ferris, who used to be with the Wildlife Conservation Society, she's basically on her own now. And then Luke George from Humboldt State University, Bill Loudenslayer, retired from the Forest Service, and Steve Zach of the Wildlife Conservation Society have done much of the work or been involved in parts of what I will be talking about. The thing I want to bring up first is the idea of scale and what we can actually study in various experiments. And most of the experiments, what I will be talking about and what most people have been able to actually do is at the stand scale. We can say something about the stand scale, our Blacks Mountain study, the Goose Nest AMA study, and other studies that are going on. And it's because of the amount of space that's needed to be able to do replication for statistical power. Now, I don't know of any really studies that are experimental in nature that have been done at the landscape scale. In other words, treating multiple landscapes and to be able to test them that way. Most landscape scale type of work is retrospective, where you look at a landscape, you try to describe the patterns in it, you look at how it may have changed over time, and then if you look at enough landscapes that way, hopefully you get something from it. So essentially what I'll be talking about is the first scale, is the stand scale, because that's where we can actually do our experiments. And the three projects I'll talk about are, first one is the Blacks Mountain Interdisciplinary Ecological Study, which is on the Blacks Mountain Experimental Forest in the Lassen National Forest. And that's where we were looking at the ecological effects of stand structural complexity. And then we serendipitously had the cone fire that gave us some idea of how fire actually behaved in these places that we altered the stand structure. Then I want to talk about the Goose Nest Adaptive Management Area Study, which also is combined with the National Fire Surrogate Study site on the Klamath National Forest. And there we were looking at the ecological effects of accelerating the growth of large trees, as well as the ecological effects of fire hazard reduction treatments. And then we'll see how much time there is left, and I'll describe briefly a study that is, experiment that is actually just going in place now, that is a variable density thinning study on the Stanislaus Tuolumne Experimental Forest and Stanislaus National Forest. And there, what we're looking at, and Eric Knapp is the lead on this, is the ecological effects of restoring variable tree density within stand density variation. So those are the projects I want to talk about. And this is where they're located. Blacks Mountain is in the northeast, on the east side of the Cascades in the Lassen. It's there in the white, and then the Goose Nest area is up just north of Mount Shasta, and then the variable density study is in the Central Sierra. To start with the Blacks Mountain study, the objective there, like I said, was to understand the ecological ramifications of within stand structural complexity. And what we did, what we decided to do in this study to look at this question was to compare a place that has most of the large trees left in it compared to a place where we don't have the big trees anymore. And so we came up with what we called two different treatments, one called high diversity, one called low diversity. And in the high diversity treatment, we left all the large trees. And within the stands, and these stands are basically about 250 acres in size, and that's wildlife driven. The wildlife biologists told us that they wouldn't be able to learn much of anything unless we had a big area that we were working with in terms of wildlife. And so we came up with an average of about 250 acres per treatment stand. And within each stand is, we leave, in this high diversity case, all the large trees. 10 to 15% of the stand is left untreated in kind of thickets and so forth. And then we also 10 to 15% of the stand is turned into quarter-acre to 2-acre gaps. And then the rest of the stand is thinned from below, leaving the large trees. The low diversity is, in contrast to that, is where we remove all the big trees, the old growth, and then the intermediate sized trees are what we were targeting leaving, and then they are fairly evenly spaced as much as we can make them, and it actually kind of mimics a lot of what's been done in the Eastside pine in northeastern California. And so these are our two contrasting treatments, and it looks sort of like this, the way it was factored over the landscape. You have high structural diversity on the top, low structural diversity in the bottom. Each of these 250-acre stands is split into two. Half of it, we put prescribed fire in it after the treatment is done. Half of it, prescribed fire is kept out. And then we had 12 of these units overall. 6 of them were left open to grazing, and 6 of them were fenced to keep the cattle out, so there would be no grazing, to see how they would, how things would progress over time. And this is how they're arrayed on the landscape. And what you see is this is a 10,000-acre Blacks Mountain experimental forest, and the areas in green are our high diversity plots. The areas in yellow are the low diversity plots. And then what you see is how they're split. Each one is split into prescribed burn where it's cross-hatched, and then unburned is just solid. And then whoops, going the wrong way. Then if they have a cow in it, they're grazed. And then the purple areas are a research natural area that we use. They're units of a research natural area that we use as pseudo-controls. They're not true controls because they are where they are, and we weren't able to randomly assign it. What we did do, though, was to randomly assign which 2 were where we introduced prescribed fire into them and which 2 we did not. But they've never been logged, and we fenced them as well to keep the cattle out and so forth, although we don't have money to maintain that anymore, and so the fences are coming down. And but we did put prescribed fire into 2. And so what we were working from is what original stand structures potentially looked like, and this is a photograph from the Blacks Mountain Experimental Forest early in the 20th century when the forest was just being set up. And then this is a photograph from the 1990s as to how the structure had changed over time. And so we wanted to push things back more towards what the historical photograph was telling us would have been stand structure in one sense. Lots of large trees, only widely spaced. And you can look at how fire occurrence, well, that's interesting, my graph didn't show up at all. So you'll just have to believe me that there's been a big pulse that occurred at about the time of actually grazing came in, and fires ceased at the time that grazing came into Blacks Mountain, and the big pulse of trees began at that time, and that's what's grown in to become the denser stands now. Now here's what our untreated research natural area looks like, typical photograph. And then if you put fire into it, this 1 year post-treatment, this is a photograph of how that looked. You see there's a lot of little trees that were killed. The big trees are still there. And the surface fuels are kind of cleaned up. But this is what it looks like 4 years later. And you can see the small stuff is all coming down on the ground. And large trees are still there, but some of them have died too since. And we actually have a pretty nasty fuel situation in these areas, and we're trying to get in and reburn them again. We believe that it will probably take 2 to 3 applications of fire in the research natural area to approach the stand conditions that we would like, with reducing the fuels and opening them up somewhat to mimic the more natural stands. Now this is what the each treatment looks like. Large trees, a high diversity stand followed by no prescribed fires, so you can see the fuels on the ground in there. This is large trees remaining and prescribed fire used, and so most of the surface fuels were cleaned up, and you have a lot of herbaceous and grass. And then this is remove the big trees and pretty much just thin out everything else to have a fairly uniform stand of intermediate sized trees without fire, and so you can see a lot of fuel on the ground. And then here's the same kind of situation, the low diversity stand, after we had put fire in. And so there again, you can see that a lot of the surface woody material has been removed by the fire. You have a good cover of herbaceous and grasses and so forth there. So I think might be a good time for some questions, if anybody has one. Ended up with the cone fire coming through after we had done the treatments, and doing a number on Black's Mountain, burned several thousand acres within the experimental forest, and you never know what fire is going to do. I like this picture where it burned our sign away that says you're entering the experimental forest, but it left the frame for the sign in there, and that's Bill Oliver standing next to it. But the fire allowed us to see the effectiveness of the stand structure changes that we had made. I'm not going to spend a lot of time on this because I've given a lot of these talks and other people are somewhat familiar with it. But here's a photograph from the air of the fire, and right after it had occurred, and the white in there is ash from the fire having just gone through and burning fairly hot in some places. And this was in September of 2002. It followed the longest period without rain we'd ever recorded in this part of California. Shows you where the origin was and then what direction the wind was blowing. It was a north wind conditions in September, and then we also had a single-digit humidity, relative humidity that day. So it was very dry. And these areas are where the unthinned areas were, and this was our treatment area, where one side had been thinned with no prescribed burning and the other side was thinned followed by prescribed burning. This is just one of our treated areas, and you could see how in the thinned and no prescribed burn the fire made its way through there. It didn't in the prescribed burn one, and and I'll show you what the results were. But it's interesting that if you summarize it, survival was greatest in areas that had both thinning and prescribed fire prior to the cone fire event. That's basically, we lost very few except right on the edges of the thinned areas where they're mostly being influenced by the heat from the severe fire that was burning outside of the thinned area. Survival in the thinned area, in thin-only areas, was greater than untreated areas, but substantially less than areas that had both thinning followed by prescribed fire. And that didn't matter whether it was the high diversity or the low diversity type of treatment. Bowl scorch and crown scorch was substantially reduced in treated areas, and that's what led to better survival there. And this is what they looked like, maybe. Nope, it's not going to show it. I don't know why it's not showing up. Well, that one shows up. The no treatment ones are pretty well toasted. The thinned with no prescribed fire is kind of interesting. You can't see it there. At least I can't see it. And but what it is that the fire dropped to the ground immediately upon entering it, but because we had not used prescribed fire, the fire continued through on the surface, and with sufficient intensity as a surface fire to scorch a lot of the trees and to do enough bowl damage that over half of the trees were killed in the stand anyway. And then what you see in the lower right there, that was where we had thin followed up with a prescribed fire, and you can see that the fire just poked on the surface as a very low intensity fire through there. And this is what the stands, data about the stands, how we change them. If you look at what this looks like is that the area that is the 0 to 50 meters outside is the fire burning. This is what the conditions were like right outside of our treated areas, out to 0 to 50 meters outside. This is the first 50 meters inside, and then this is the second 50 meters, or 50 to 100 meters, and inside as to what we had. And so you see here is trees per acre, and what we did, the outside is somewhere a little over 800 trees per acre, where we took it down to something a little less than 100. And then what you have in this chart over here is basal area. And again, this is immediately outside, and then these are transects that we put in after the fire, and to show you what the differences were along those transects, and what difference it had made. And then here, what you have is the basal area, which is the amount of area occupied by the main stem of the trees. And so we basically had about 132 square feet per acre immediately adjacent to the treated area, and then inside we took it down to around 40, is in this particular site that I'm showing you right here. So that's the low diversity, and then here is how high diversity looks. And it's quite different in one regard. It's the same kind of pattern in the sense that this is trees per acre, and you can see it was still pretty dense at about 900 trees per acre here, and we took it down to around 100 trees per acre within. But look at the basal area and how that almost doesn't change. And the reason for the no change is because in the high diversity stands, we kept the big trees. And so the amount of area occupied by those big trees was sufficient, even though we took out many, many little trees out of there. The main stem of the tree is so small that it didn't account for that much area occupied. And so the amount of basal area remained very close within the treated area to what the area outside had been. We just removed the ladder fuels and the small trees in the understory. Now here's what we found happening at Black's Mountain, that over a period of 65 years, that was the first census was in the 1930s, and then since then we've done a couple of different censusing of what's happening with the trees there. And the condition of the large old trees at Black's Mountain has deteriorated substantially, even where we haven't removed them. And there was the influx of the young poles and saplings and a substantial increase in density of large trees greater than 24 inches, in a decrease in density of large trees greater than 24 inches in diameter. In other words, we have so much density of trees out there in the untreated areas that when the big trees die and fall over, the small ones are still competing with each other to the point that that they're not really growing into that space and becoming the large trees to take the place of the ones that are falling over, because there's just too many of them. And now that's different where we've done our treatments. And then an evaluation of post-treatment survival and growth indicates that the decline is continuing in untreated in the research natural areas. And Martin Ritchie just published on this a couple of years ago, and showing how the difference in the condition of the trees where we've done, the big old trees where we've done our treatments, compared to the research natural areas where no treatments have been done. And it basically, we're losing the old tree component in the research natural areas. And whereas the trees are actually showing increased vigor in the areas where we've treated. Treated stands have much lower rates of mortality and even have higher growth rates in the old trees, increasing the numbers of large trees. And this is kind of interesting. If you look at the risk of dying, and this is looking at the condition of the crowns and how they, how full the crowns are and how well the trees seem to be doing in that regard. If you compare the high diversity stands, which are these two on the left, this is unburned stands, these are the burned ones, and then to the research natural area where no logging has gone on, what you see is that in the areas where, in the research natural areas, that 50 to 70% of the trees are considered at high risk of dying in the next 10 years, whereas in the treated areas now, several years after we've done the treatments and the trees have had the opportunity to regain vigor, what you see is that it's only about 10% or 15 to 10% of the trees now look like they're at high risk of dying in the next 10 years. And many of them are at very low risk, almost half. So you can see that they've responded very well to the treatments that we have put in there in terms of helping to improve the longevity of the large old trees. Uh-oh. Now here's another one that's not showing up very well. So this would be a hard one to explain without seeing the graph in the back. I'm not sure why that's not showing up. So I'll go on instead of spending time on that one. People always want to know about the cost. How much did it cost one way or the other? So our low diversity treatments where we removed all the big trees basically netted $2,600 per acre. For those where we put fire in, because there was a cost to putting the fire in there, then you netted about $2,475 per acre on average. Now the high diversity where we kept all the big trees and just took the small trees out and so forth cost us $300 an acre. And then where we put fire in, it cost $425 an acre. And so you can see there's considerable difference there. And so it could be that, in a practical methodology, if what you would like to do is keep a lot of your big trees and but make them more, reduce the fire hazard around them, then maybe some low diversity could help for paying a whole lot of acres of the other. Now in the research natural areas where all we did was put fire in, that cost us basically $310 an acre. And if you look at the differences in the other costs, it looks like, wow, burning in the research natural areas was a whole lot more expensive than burning in the others, and that was essentially the case. It costs considerably more to burn in the research natural areas where no pretreatments had been done, and that's primarily because of the amount of fuel and the ladder fuels and trying to get the right prescriptions to be able to actually get fire to go through there but not mess up the stand, where you had much wider burning windows for the areas of where we had done the thinning. It was interesting too because say you have equivalent crews, size crews, you could burn 2 of the treated stands in a single day compared to a research natural area where it took 2 days to burn one of the equivalent size stands. So that's the difference in why there's so much difference in cost. Okay, animals. And like I said, we're at the stand scale, so we can't look at some of the big wide-ranging animals and so forth, or something like spotted owls that need large areas that are probably almost the size that we treated totally. And so what we did was we chose to look at small mammals and other birds that have smaller territories or respond at stand scales to the treatments, and thinking that they're the prey for the other critters. And so in that case, what we found was that at Black's Mountain, anyway, that the yellow pine chipmunk, golden-mantled ground squirrel, and deer mouse accounted for 80% of the biomass of the small mammals that were collected there. And it was interesting that if you looked at how they responded, that the yellow pine chipmunks and the deer mice seemed to like the more open areas that didn't have so much the large trees, but the golden-mantled ground squirrel was just the opposite. It seemed to be found more commonly with where the biggest trees were, and that's what the next thing says, is that the golden-mantled ground squirrels were captured more frequently in high structural diversity treatments, whereas yellow pine chipmunks were captured more frequently in low structural diversity treatments. So it's kind of, one was good for one and the other was good for the other, but they were pretty much all found in both. It's just that they were more dominant in one or the other. Now the birds, this one was interesting to us, is that for one thing, Black's Mountain had a higher abundance of woodpeckers and bark-gleaning bird species, and a lesser abundance of foliage-gleaning bird species relative to typical eastside ponderosa pine. And we think there's a number of reasons for that, and I'll get to that in just a minute, that there were not a lot of differences in occupancy of bird species. No differences in species richness were found between the structural different treatments. And essentially what we found was that the species that were there before kind of stayed on even after the treatments, and which was not expected. They thought there would be more of a change than there was, and it may be that we just haven't followed it long enough yet, because a lot of species are very loyal to their territories. But species richness did not change with the structural treatments or with prescribed fire. Basically, they all were found everywhere. It's just that some were found more commonly some places than others. Now the treatments themselves, and this might be one of the reasons that we didn't see a lot of changes, is that we left all the big old snags that were in there. We didn't take the snags out. And so snag retention might partially explain why there were no substantial shifts in the species richness after treatment. And so even in those places where we removed all the large live trees, we left the snags. And some of the wildlife biologists are saying that if he was to do it over again, he might have some of the units where we just got rid of the snags too, to see what that would have done. We didn't do it in this particular project. So that's what I have as a summary for Black's Mountain. Are there any questions, again, at this point?
Carl, it's 2:50, and I think we're going to have quite a few questions here. I'm not sure whether we should truncate the presentation. What do you think?
Well, I could...
I would suggest continuing with the presentation and then see where we are at the end with regard to questions, and then we can follow up with answers to questions after the webinar if necessary.
Okay. Well, Carl, how much time would you think to go through Goose Nest and the Tuolumne one?
I'm not going to go through Tuolumne, I don't think. That's just, that was if there was time to get to it. I'll just go through the Goose Nest. And it probably would be good to keep questions until after that anyway, because they're very similar results.
Okay. All right. Well, then let's hold questions that people are posing here. People should have caught up now with the slides, and then we'll take the time at the end for all of the questions that we have, because we have several questions.
Okay.
Okay. So why don't we just move forward?
Okay, the Goose Nest Adaptive Management Study was basically our objective there was to accelerate the development of large tree component and for late successional kind of conditions. And that's because it had all been removed in railroad logging early in the 20th century, and it was about a 70-year-old stand regrowing. And it was in an adaptive management area set aside by the Northwest Forest Plan for doing different kinds of work to try to accelerate the late soil conditions. And so what we chose to do here was to a number of different kinds of treatments that were emphasizing pine, which was the main tree there to begin with, and keeping all the large dominant and co-dominant pines, and then spacing other trees out depending upon what the diameters were of those trees, instead of having them be evenly spaced. And then creating some openings where there were no pines, mostly fir, and planting them. And that would be 1/2 acre to 3 acres. Large tree, and then we had another treatment called the large tree emphasis, where it didn't matter what species they were, we just kept the big trees and then thinned between them. These were 100-acre units with buffer. There's 5 replications of 3 of the different treatments. And it's fully multidisciplinary. It looks like this, controls, and pine emphasis, big tree, and these are all of the interdisciplinary groups that were involved in planning the study. And then we also, in the same area, put in the National Fire Surrogate Study, which was looking at what the effects of reducing fire hazard would be. And with this one, we added another treatment, which was fire only and no thinning. This is what the stands looked like. Untreated controls. This is mechanical with thinning and no fire. This is prescribed fire alone. And then this is the mechanical thinning plus prescribed burn. And this one's not working, so that'll speed it up. And that one didn't work either. So the point of this last one, even though you can't see it, is that a lot of standards and guides in forest land management plans are that we're in late successional kind of forests trying to have 60% crown cover as a target. And what we found was in these stands before logging, and this is in Blacks Mountain, even in the research natural areas where they have never been logged, we did not have 60% crown cover. And so it's kind of like, if that's what your objective is, that's pretty much impossible to get to in some of these more drier east side type forests. Now, I'll get to some of the wildlife stuff there then. One of the things that was interesting was the ground nesting birds, and this is an example, is the dark-eyed junco. One of the species that a graduate student studied strongly was, our hypothesis was that when we put fire in, we were going to be removing a lot of what they use for nesting and their habitat, and so we would probably decrease the use of the dark-eyed junco in those stands that were thinned and then followed with fire, as opposed to those that we left fire out of. What they found was actually just the opposite. They found that what they thought was going to be a negative effect of prescribed burning through reduction of litter and increase in bare ground was actually offset by novel nesting strategies. They used stump holes, they used other places like that they could find, and there was an increase in the food availability, insects and so forth that they preyed on, to the point that actually we had an increase in the use of those areas by the dark-eyed junco compared to the areas that had not been burned. So that's just an example of where things did not go according to our hypotheses. Bark foraging birds. In general, bark foraging birds did well in the treated stands. And the conditions that they were more strongly associated with were large diameter trees and the beetles that were in there. And basically it makes sense, because if you remove a lot of the smaller trees that don't have very much bole and are mostly foliage, and then you expose, now you have mostly the larger trees that have much more bole and not as much of a ratio of crown to bole, then you're improving conditions for bark foraging birds. And so they're the ones that seem to do really well in the treated areas compared to others. And if you compare Blacks Mountain to the goose nest, what we found is that Black's Mountain seemed to have more activity of the woodpeckers, bark gleaners, and fly catchers. And Goose Nest was basically where a lot of the foliage gleaners seemed to do much better overall, and that's because of they were just the smaller trees, younger trees, and a lot more foliage. So there was no difference in diversity, though. Basically, they were all found in all of the treatments. It's just some were more emphasized in other places. Small mammals. And one of the things that was found was that the response to treatments were generally subtle and short-lived. And in fact, this was found nationwide in the essentially in the fire surrogate study, because that study had 12 sites from Florida to Washington, with 3 in California, and this was a general statement that seemed to be found throughout, was that essentially the treatments, what responses there were short-lived. Conditions they were more strongly associated with were how much surface wood was there and how much understory shrubs and herbs. But it depended on the species as to how they responded, and similar to what I already described to you at Black's Mountain.